Okay, now let's consider moles of molecules. This is similar to moles of atoms. We just count the moles of individual molecules. So say if we have our water molecule again, the molecular formula is H2O, and the molecular weight is equal to 18.02 grams per mole. Another symbol that we'll use a lot for molecular weight is a capital M with a sub W, standing for molecular weight. This means that if we have 1 mole of water, it would weigh 18.02 grams. Now we can count the individual water molecules. So, say if we have 10.0 grams of water, and we want to know how many moles that is, we can multiply by our conversion factor, which is the molecular weight. So we have 1 mole of water, and that weighs 18.02 grams, giving us 0.555 moles of water. Now say if we had 7.0 moles of water, and we wanted to know how much that weighed, we can multiply by the molecular weight again, which is 18.02 grams per mole, giving us 126 grams of water. Since there are only 2 significant figures in 7.0, I would round that to 130 grams of water. Okay, let's say that I have the aluminum chloride molecule. So I have 1 aluminum atom and 3 chlorine atoms. So the molecular weight would equal to the sum of the aluminum atom atomic weight, 26.98 grams per mole, plus 3 times the atomic weight of chlorine, 35.45 grams per mole, giving me 133.3 grams per mole for the molecular weight of aluminum chloride. Okay, let's say I have 10.0 grams of aluminum chloride, and I want to know how many moles of chlorine atoms I have. Okay, first I would have to find how many moles of aluminum chloride molecules I have, and then there are 3 chlorine atoms per every molecule of aluminum chloride. So I start with 10 grams of aluminum chloride. I'm going to find out how many moles that is. So 1 mole of aluminum chloride weighs 133.3 grams. So that will give me 0.075 moles of aluminum chloride molecules. Now, I'll take that many moles of aluminum chloride and multiply it by the atom ratios in the molecular formula. There are 3 moles of chlorine atoms per every 1 mole of aluminum chloride. So that will give me 0.23 moles of chlorine atoms. Another way of looking at this is, say you have 4 cars and there are 4 tires per car. That would equal 16 tires total. So each car is like a molecule, and there are 4 tires attached to the car. And so if you have 4 cars, you have 16 tires. If you have 1 aluminum chloride, you would have 3 chlorines attached to that molecule. So for every 1 aluminum chloride, you would have 3 chlorines. So if you have 4 aluminum chloride molecules, you would have 3 chlorines per every molecule. So that would be 12 chlorine atoms. Now I want you to notice how these units are handled. These words can be handled just like numbers. So here I have 4 times cars. And then I multiply by 4 times tires per 1 times car. So cars cancels, and I'm left with 16 times tires. So I'm going to use atoms and molecule names just like cars and tire names, so they can cancel. So if I'm in doubt of how to do a calculation, like calculating grams from moles or moles from grams, just use the molecular weight. Like aluminum chloride has a molecular weight of 133 grams per mole. So I can use 133 grams per mole, or I can use 1 mole per 133 grams, depending on how I want my units to cancel.